Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous lecture we had started our discussion on word tokenization. So, what we will do a small recap of 2-3 approaches that we were able to cover in the previous lecture, and then we will move forward to other aspects of tokenization and other steps as well. So, word tokenization, we talked about first approach, that is using the default and recommended word tokenizer, that is using the word underscore tokenize function. So, we looked at this particular function and used Emma text that we have been using for to demonstrate these tokenization examples. We can have a look at output here again. We also discussed another approach, second approach, using tree bank word tokenizer. So, internally this is based on regular expression. So, here however this is typically used to convert sentence into word tokens. So, we took the example of Emma underscore sends 0, and we used that to create tokens here. So, you can see tree bank underscore wt dot tokenize, and we were able to create these tokens. You can see few aspects how it could be different from the default tokenizer, that also we discussed. Then we move to the next approach, that is third approach, where we use the regular expressions. So, we define our patterns, and those regular expression based pattern can then be used to create regular expression object, regex objects, and then we can call tokenize method there and perform our word tokenization. So, we looked at this aspect as well, and we saw that how we were able to get rid of any kind of punctuation tokens, which are punctuation marks, which have also become tokens in the previous two approaches. So, we looked at how using regular expression we got nicer tokens there. Then we also discuss another regular expression approach. In the sense, we change the pattern and mainly to identify gaps, and we saw as an output that slight difference in terms of tokens. So, we didn't have any tokens with having just punctuation marks, but a few tokens were different in the sense because we were trying to identify gaps there. We also looked at start and end indices when we are using this regex approach, and how they can be used to compile the tokens that we are producing there. So, these approaches we are able to cover. Now, let us talk about the fourth approach that is there for word tokenization. So, we can use derived classes of different types of word tokenization as well. And so, for example, word punct tokenizer class, we can use an instance of this class to perform our word tokenization. Independent alphabetic and non-alphabetic tokens, for example, we can obtain using an instance of this class. So, we can use word punct tokenizer function here to create the instance of this particular class, word punct underscore wt. So, let me run this, and then we can call the tokenize function using this object word punct underscore wt dot tokenize, and let me run this. We will have the word tokens. Let us have a look at the first 500 tokens here. So, you can see the output is quite similar to the previous output that we have had, and in this particular case we will have the alphabetic and non-alphabetic tokens independent, separate. So, you can see again in that sense the output is quite similar to the previous outputs here. You can see now opening bracket, comma, they have also become tokens. So, let us move forward. Now, we will take another derived class here, white space tokenizer class. So, we will take an instance of this white space tokenizer class. So, this is based on again based on white spaces. So, we will use the white space tokenizer function here to create an object instance. So, white space underscore wt by calling nltk dot white space tokenizer. So, we will have this object. We will use this object to call tokenize method on Emma, and we will have our set of tokens. Let us have a look at the tokens here. So, you can see again the output is similar, but you would see that the tokens slight differences. that in the sense that we are not seeing now punctuation marks as being taken as tokens in this one as well, because this is based on the white spaces. So, different approaches to create word tokenization and slightly varying output. So, depending on our requirement for depending on our problem and the kind of text corpus we might have, we might go for any of those approaches there. Now, let us move to the next aspect here. So, that is about removing special characters. So, now some of these word tokenization approaches that we talked about, they had the special characters also as tokens. So, what we can do about removing them? So, this particular removing a special character thing is, as you would understand, in the programming world, it can even be done before tokenization or after tokenization, because essentially this is a programming problem, in the sense only the input format is going to be changing. So, when we have done the tokenization, we will be removing these special characters which have now become tokens, and if we have not done tokenization, then we will be removing these special characters from the text itself. So, both are possible in the programming context. So, we will discuss both of these scenarios here. So, for this removing special characters, we would be using these libraries import. So, we will import them, import a RE and a string, and let us first take the case of after tokenization. So, in the first approach, we will take a regular expression pattern, and in this pattern we are going to use this string dot punctuation attribute, and this attribute actually consists of all possible combination, all possible special characters or symbols, because our idea is to remove special characters and symbols. So, this particular attribute will help us, in the sense it has exhaustive list of all those characters. So, our regular expression pattern will take will use this particular attribute. Then if you look at the pattern that we are trying to define here, we are using the re dot compile function here to compile this pattern, and in the parenthesis you see that we are using string dot punctuation, that there we are escaping this using re dot escape function here, so that those special characters are escaped out, and then we are calling format here. That is mainly to copy the pattern string that would be created, and will replace the copy this string into the replacement field denoted by braces there. So, using this we will have the pattern, and then we will be compiling this. So, in one go we would be doing all this, and we will have our pattern. Now, once this is done, once we have the pattern object here, we can use a list comprehension, which is going to be based on sub method, and we will find all matching tokens as per the pattern. So, we will apply this pattern on our text that we have. So, the text right now we are dealing with the after tokenization scenario. So, we will have our tokens. So, we will apply this pattern on these tokens, and all the matching tokens they will be found they will be able to find out them, and then they will replace them with the empty string. So, the same thing is here in this particular code, you can have a look. Here if you look at the this list comprehension, we are calling pattern 4 dot sub and empty string comma token, and this token is coming from Emma underscore words that we have already computed. Word tokenization we have already performed. So, for each token that is there in Emma words, we will be applying this pattern, and we will be replacing these tokens wherever they are special characters or symbols are matching with the empty string. Then we are calling or we are doing all this within the filter function. So, because in the filter function the first argument is none. So, we are passing none as the function to be applied here. So, essentially all the empty tokens are going to be removed here. If you are interested in finding out more about the filter function, you can always go to the help section, and we can go to the Python reference, and we can have a look at what this filter function is about. because some of these functions are quite useful in text processing. So, sometimes it is better that we have a look at them using our help reference, so that we have better idea about the arguments and the kind of processing that will be done by those functions, and also the returned value that is going to be there. So, filter. So, you can see in this filter function, you can see that it is going to construct an iterator from those elements of the iterable in the second argument that is there. And primarily you can focus on this part. You can see if function is none, the identity function is assumed, and that is all elements of iterable that are false are removed. So, this is essentially what we want. We have specified none, and therefore, identity function is going to be there. We would like to remove the empty tokens there. So, that is what we want. So, this is what we can achieve using this particular function. So, let us go back, and and then output of this particular function would be is going to be an iteratable object. So, therefore, we are using list function here to create a list, so that we can have a output there. So, let me run this, and let us have a look at the first 500 tokens here. So, you can see now that if you look at the tokens, so you will not find any special characters as independent tokens here. So, it start with Emma, by, Jane, and you can see we can keep on going like this. We can keep on scrolling, and you would see that all the tokens, and all these tokens are meaningful English language words. So, you can see. So, in this fashion we are able to actually remove all these special characters. Now, we can also have a look at the Emma words without when we did not have we did not remove the special characters. You can see opening bracket, closing bracket, comma, and all those things they are clearly visible here. So, all these things are gone. So, all these characters are removed. So, you can see here in the output dot is also there. So, various comma is also there. So, various punctuation mark they have been they were treated, semicolon is also there, they were treated as tokens. So, now all those are gone. So, even after tokenization we can we can remove these special characters. So, that is one scenario. Now, second scenario is could be before tokenization. So, can we remove these special character before tokenization? So, let us talk about the first approach that we can adopt. So, in this again we can use the regular expression pattern, and let us focus on extracting alphanumeric characters, because essentially the meaningful tokens would be comprising of alphanumeric characters. So, we can define a pattern to actually perform that. So, we will be adding characters to be retained here. So, pattern 5 you can have a look. We have a smaller A to Z case, the capital A to Z case, and 0 to 9 and the space. That is something that we would like to have in the pattern. So, let us define the pattern here. Now, remember this this scenario is before tokenization. That means, the input is actually text in the text form. We do not have tokens here. So, we will be working, these patterns are going to be used on text content directly before tokenization. So, first thing is that we can use a strip method to remove white spaces. So, if there are any white spaces, we would like to get rid of them. Then second thing is we can use this list comprehension, and here also we are calling this using this sub method to find all matching tokens as per the pattern. So, let us say Emma underscore sends. You remember that we had used this we had called this sends method, and we had obtained sentences from Emma. So, for every sentence in that particular output Emma underscore sends object, we can run this, we can call this sub method, and in this first thing we are stripping the sentence from white spaces, and then we are applying pattern, and wherever as per our pattern those characters are not there, so those are going to be removed. So, if I run this and let us have a look at the 500 characters here. So, you can see that the output here. So, you can see Emma, and we had the brackets there. So, all those are gone, many other things you can see, all text is looking much nicer, in the sense the punctuation and special characters you will not see many of them. So, you can see many of those things are gone, and we have a nicer looking output here. So, this is another approach that can be used, and you can compare this with the Emma underscore sends output. So, we have this here. So, you can see all brackets, opening brackets, closing brackets, slash, and all those things are gone, dot. So, all those things period character, all those things are gone here. So, you can compare the output here, double dash, all those things you will not be able to see now. Now, let us talk about another approach that can be used, second approach that can be used to remove these special characters. So, in this approach again we will create a regex pattern. Now, however, we would like to if we decide to retain certain special characters. So, this approach could be more suitable in those scenarios. So, for example, we would like to retain apostrophes and sentence period, because apostrophes might give meaning to certain words. So, therefore, maybe we would like to prefer to retain them, and the sentence periods also, because it could for further processing it could be really useful delimiter. So, maybe we would like to retain them. So, in the next pattern that we are going to define, we will just add characters to be removed. So, you can see that what kind of characters we are combining, putting in this pattern, defining in this pattern. You can see question mark or dollar or ampersand or asterisk or percentage or at or so different tilde, and or symbol for or. So, all these characters are there that now we would like to remove. So, let me define this pattern, and then how we are going to perform. So, similar kind of list comprehension we are going to use here. So, you can see for sentence in Emma underscore sends that we already have. So, for each of the sentence in that particular text. So, you can remember that Emma underscore sends is the non tokenized untokenized text that we had. So, from that we are extracting sentence. For each sentence we are first stripping, then matching the pattern, and the pattern is found, then we are replacing that with the empty tokens. So, if I run this and let us have a look at the output. So, if I scroll back and have a look at the output, now you would see that slash n's are back, and many other things dot are back, and you would also see that many other things which are not part of pattern that we have. So, you can see double dashes are also back, and you would also see that apostrophes are also bad. So, if you are not able to spot some of those for example, Emma's situation, you can see here the real labels indeed of Emma's apostrophes are back now, which were gone earlier. So, you can see different kind of regular expression and different kind of output we have gone. So, removing special characters, we can define our own regular expression based pattern and use that to actually process the textual content, text whatever we have. So, it can be done before tokenization also and after tokenization also, because essentially we are processing text. We have enough programming constructs available in Python to actually perform this quite easily. So, this was about removing special characters. Now, we will move on to the next aspect, that is that we might have to perform so, this is about expanding contractions. So, what we mean by these contractions? So, as you would understand that in English language formally we we typically write like will not, is not, but sometimes in informal language we might write isn't or won't or can't. So if there are in your text, if both kind of both kind of these contractions and expansion, both kind of forms are present, then it might create problem for your further steps, tokenization and many other steps that we will be discussing in coming lectures. So it would be better if we are able to get the same form, and if we talk about contraction and expansion, then we will prefer the expanded form here. So we that is as per the formal writing. So we would like to replace isn't to is not and won't to will not. So for this we need to have a mapping for this, so that we are able to whenever we are trying to find out where we are trying to we are using regular expression to find out these contraction, we should have a mapping so that we are able to replace these contraction with their corresponding expansion. So for this, here we are defining a slightly or exhaustive list of contraction map here. So you can see aren't or not, can't, cannot. So in this fashion you can see this is a dict object we have, and we have key value combination, and key we have the contraction, and the value we have the expansion. So we can use this to provide the mapping, and later on we will see we will use this mapping. So this is quite an exhaustive list. You just scroll through, and so we can use these kind of list to actually do certain kind of text processing where we require full form. We prefer full form for text analytics rather than the contractions there. So next thing is that we will write a function to expand these contractions in the text. So let us define a function here. So our function is def the keyword and expand underscore contractions, and we have two arguments for this function, send two parameters, sent and mapping here. So sent is for the sentence which we will be processing, and where we will be finding out the contractions and then replacing it those with the expansion. So mapping is the mapping that we just that I just showed you, that is going to be used, that dict object that I just showed you, that is going to be used to map out the contraction with the expansion. So we will be referring to this mapping, and any sentence that is there we will be processing that. So the our this function this is going to be using these two arguments here. Now first thing we need a pattern for matching contractions with their expansion. So let us have a look at this pattern. So here we are calling re.compile function to actually compile this pattern object here, regular expression here. So you can see here also we have the first argument we have the curly braces, so that will be constructing this regular expression and replacing in this delimited space using the braces. So we are calling format here format method here, and you can see this join we have used before also. So in this join we are calling mapping dot keys, and using format we are going to create all the keys and their mapping, because essentially we will be matching pattern with the text that is there where these contractions are present. And we have also defined certain flags, for example ignore case and all. And for more details on format and other methods that we are using, you can always refer the help section there. So with this we have defined our pattern. Now the next thing is we are again defining another function expand underscore map. So what it will do, it will take a contraction and map it out to an expansion. So it will return the expansion, it will take contraction as the input, and output would be expansion. So within this we are calling a group method for the match object that we learned during our discussion of regular expression to access subgroups. So let us say we have found a match certain occurrence based on our pattern. So that if that is stored in a match object, so subgroups we can access using the group method here. So, let us say we have got the contraction dot group 0. So, first subgroup will get first match will get. Then next thing that we are doing is we are retaining, we are storing the first character, because we would like to retain the correct case of the word. So, for that purpose we would like to store the match 0 here. Then next thing is the core thing of this function, find out the expansion. That means, based on the given contraction that we are passing, we will like to find out the expansion. So, here we are using ternary expression. So, mapping dot get, we have the mapping. So, we are using the get method to based on the match will get the value part, based the key part is going to be passed on, which is the contraction, will get the value part. So, if it is true, then we will use that. If it is false, then it might be present in the lower case. So, in the else part we have covered that scenario. So, we will have the expansion here, and then we are again reassembling our expansion here using first underscore character plus expansion starting from character with the index 1. So, second character. So, this is to retain the correct case of the word as we discussed, and then we will return the expansion. So, in this fashion any contraction we would be able to map it to its appropriate expansion using, as we discussed, using the particular pattern that we are going to compile. Now, after this once this is done, then within the expand underscore contraction we are going to call this expand underscore map. So, you can, as you can see, the arguments we had is sent is also being passed to expand underscore contractions. So, therefore, we are going to process the sentence here itself in this function itself. So, the next thing is we are calling the sub method, and first argument is this expand underscore map function. So, this function is going to be applied and on sentence. So, any occurrences that are there. So, we will use this sub method to replace all contractions with their expansion for a sentence. So, function expand underscore map that we just discussed will be called for every non overlapping occurrence of the pattern. So, any occurrence of the pattern that we get using the pattern. So, for that expand underscore map will be called, and for that means we will, for any contraction we will have the expansion, and that is going to be used to replace the occurrences in the sentence that we have passed. So, in this fashion finally we will be able to return the expanded sentence where all the contractions would have been replaced with the with their appropriate expansions. So, with this let me run this, so that we have access to this user defined function. Now, once we have done, the next thing now the next thing that we require is to use this function. So, first we will take this test string here. So, in this double quotes I am using this string, the young man was not fast enough and he could not win the race. So, in this case, as you can see in the test string that we have wasn't is there, which is a contraction, and then couldn't is there, which is a contraction. If you go back to the mapping here, let us see whether we have covered these two, wasn't and couldn't. So, if you go back to the mapping, so you can see that here, let me scroll up a bit more. You can see wasn't is covered here, wasn't was not, and if we scroll back, couldn't might also be, I think it is covered there. You can see couldn't, could not. So, these two mappings, these two contractions are there in our our map that we had defined, the dict object that we had defined. Now, for this test string example that we have, I think we would be able to replace these contractions with their appropriate expansion. So, first line we are defining test, then the next thing we are calling this our user defined function that we just discussed, expand underscore contractions, and we are passing on the first argument, which is should be the sentence, in this case test, and our contraction mapping that we have already defined. So, if I run this, in the output 130 you can see, you can compare it with the test string, the young man was not fast enough and he could not win the race. So, you can see the contractions they have been appropriately in this case they have been appropriately replaced with the expansions that we have there. Now let us do the same exercise with our corpus here. So, AMA is the corpus that we had used. So, in the text that we have for AMA, we might not be sure whether we have these contractions present there, because this is established corpus, and it seems that formal lighting mechanism has been used. That is why to demonstrate this we had used this test string as an example, because in the AMA file that we have, it is part of the Gutenberg corpus, the formal lighting mechanism has been used. So, maybe we might not have any contractions to be replaced with their appropriate expansions, but anyway you can always run this. So, for to demonstrate on a corpus level we will use this. You can see the code is same. So, within the list comprehension, now the slide changes that in the corpus we will have a number of sentences. Test string there was just one. So, now we require a list comprehension here. So, you can see we are calling expand underscore contractions use and define function in the transformation part of the list expression, and within that sentence comma contraction underscore map. Contraction underscore map we already defined. Sentence is coming from for sentence in AMA underscore f. So, AMA underscore f is the previous output that we had produced, where we had cleaned few things there. We had used the filter section filter function there, and we had cleaned this text. So, we are going to use that particular output, and we are going to apply this expand underscore contraction function here. So, if I run this, we will have AMA underscore fe, which will actually have the will have replace the all contractions with their appropriate expansions. If I have a look at first 500, now if we look at the output, however, the only problem is that we do not know whether any contractions were present in, because this is such a long text, any contractions were present in any part of this particular text. However, you can always check it back. So, you can always write your own code to first find out whether contractions are present, or for that matter whether special characters are present in a text before applying some of these things. So, both these things that we discussed, removing special characters and replacing the contractions with appropriate expansions, whether they are present in the first place. So, if they are present, maybe only then we should be running that part of the code. So, with this we would like to stop here, and in the next lecture we will continue our discussion on this part and on some of the coming steps there. Thank you.